to this session on data science. I hope I am audible clearly. I did not switch on my video today because I'm having some Wi-Fi problems, as I mentioned to you in the WhatsApp just a while back. I have some Wi-Fi problems. My Wi-Fi server is down. My Wi-Fi network is down. I'm trying to connect using my hotspot, so I'm not sure whether that will give the backup for a long time or not. I haven't run a full course on hotspot till date. But yes, whatever is the support that we can get, we will continue with that. I don't think I will get my Wi-Fi connection back today. So fair enough. So we will get started. All right. So what we have started off in the last class is the model building aspect, right? We said we will start off with the basic perceptron model. So this is how we have visualized the basic perceptron model. And as we have discussed, for each of the models, some of the steps are very much common. We need a function that links the x values to the y value. We need an error function, which we will try to minimize in an iterative fashion. And finally, we also require how is the feedback resulting in the updation of the weights or coefficients or whatever you call. And based on that, we have looked at how this entire process typically goes, what is there in the back end, etc., etc. Then we moved forward and we went ahead and we tried to fit the model on our data, right? That is where we have fitted, and probably we have looked at a few metrics, and the metrics is what we have to focus on right now. So this was the basic perceptron model. I can run the model again now, but I think because of the network issues and all, I doubt that it would take a long time to execute. So as we have discussed, I have run this model once again in the morning to ensure that I did not do any duplication in terms of removal of the variables, etc. Instead of 10 variables, which we got yesterday, today I'm getting 13 variables. So somewhere I would have ended up removing some additional columns. So possibly you can look at running this, or it could be because of it was run until some time back on my Wi-Fi itself, but it took not Wi-Fi, sorry, the hotspot, and probably it took a good amount of time for the execution part as well. Okay, so it has executed. We have executed the basic perceptron. We have initialized the basic perceptron, then fit that basic perceptron model on the training data. In some cases, you can look at the coefficients, look at them. Wherever you are looking at the coefficients, you can very well talk about the most important variable and the least important variable. So because we have done the normalization, standardization of the data, it is very much possible that the coefficient which is having the highest value, either with a positive sign or a negative sign, is more influential, and the value variable that with the lowest coefficient, either with a positive or a negative value, so they are the least important kind of variable. Okay, But more than the variables, we want to look at the first step we will do is we will score the model on the training data itself. Scoring it on the training data is primarily to ensure whether there is any kind of underfitting in the data. So wherever there is underfitting, the most probable scenario is the model in reality is much more complex, but we try to fit it using a simple. The data is a bit more complex, but we try to fit only a simple model to that data. That is what is underfitting, right? So we are trying to fit a simple model to a complex data. Now, how do I assess that? Probably compare the model score, which is what is actually called as the accuracy score of the training data, with the default accuracy that can come up. How do I get the default accuracy? We have discussed yesterday. Look at the distribution of zeros and ones in your final data, in your actual data, and see what is the proportion of the most frequently occurring column. So most frequently occurring column is a zero column, and we could see that it has occurred almost 84% of the time. Well, so the minimum accuracy that I would expect is around 84%. But the actual accuracy that I got through using the basic perceptron model is only 78.25. So there is a fall. So even if it has to be higher only. Otherwise, why should I need a model? I will simply create a kind of a prediction saying that all of the customers will belong to the group 0 only. That's sufficient. So I'll get an 84% accuracy altogether. But my intention is not that. I have to get a much higher percentage of accuracy. And because of that, my accuracy, if I am testing it back on the training data, it should be more than this 83.98%. Even 84% is fine, but definitely not less than 83.98%. So here in this case, I can very well say that the basic perceptron model is an underfitted model to this data because it is not able to bring out that minimum levels of accuracy that is required, which is that 84 or 70, 83.98% of accuracy. It is not able to bring, which means it is typically a underfitted kind of a model. If it is underfitted, I can scrap the model there itself. But here again, if it is a good model, I have to move to the next step. So that's where I am moving on to the next step. So in the next step, I am predicting the same model what got created. So the model is something that got created. I am predicting that model on the test data. And you also find out the distribution of zeros and ones on the test data as well. You can look at the distribution of zeros and ones on the test data as well. We could see that 85.2% of the overall data is zeros, which means not defaulted, and only around 14.77%, approximately around 15% of the data have defaulted. So now I'm going ahead creating some kind of metrics on the testing data, because finally what we are looking at is some of the typical points you can see I do the test the model on training data. The objective of this exercise is to see whether there is any kind of underfitting in the data. In underfitting, as we have discussed earlier, the bias will be much higher and the variance will be much lower. So once you are able to establish that there is no underfitting in the data, test the model on testing data. What we may have to see here is the accuracy does not fall drastically from the accuracy of the above. So whatever the accuracy that comes here, there should not be a drastic drop in the accuracy when it comes here. So if there is a drastic drop in the accuracy, that is what we call as a scenario of overfitting. And because of overfitting, it might very well be possible that the variance of our model could be much higher, which means you would typically, you may not be able to predict much more appropriately. It is better to go with the testing data's results only rather than the training data results, because in some cases there could be overfitting. Normally speaking, if both of them are giving a similar kind of a result, then it means there could be a lot of better learning, sophisticated learning. With just 1 or 2% drop, then the learning might be a much better learning. But if the drop is 10% or 15%, then it means that on the training data, rather than doing some kind of a learning, there was a kind of a by hearting that has happened, and that's the reason when I gave a new testing data, the performance was not that great. So these are some of the things, and we will go with the metrics. Now, if you look at the most important thing that we will look at is the confusion matrix. We have discussed about it, but I think the numbers changed a little bit today because the number of variables has changed. So looks like the numbers have changed. So we'll call this as predicted. And we will call this as actual. So you have zeros and ones, you have 0 and 1. We have said this is called true negative, this is called true positive, this is called false positive, and this is called false negative, depending on what you are putting. Sometimes in some books, the predicted is put here and actual is put here. So accordingly, you may have to change the positions of true negative, false positive, and true positive. So if I look at the numbers, it looks like 898. Then we had a 36 here. Then 143 and 135. Right? And probably I can very well add up horizontally, which will make it 1033, and this is making 179. Add up vertically. So this is becoming 1041, right? Probably I'll call this as 1041 are predicted as zeros and 171 are predicted as ones. So that is what is the current status. Now, as I told you, okay, so that is what is the confusion matrix. I hope no one has any kind of a confusion regarding the confusion matrix. Now, what we say using all these values are typically computed. So we'll try to see how each of them are computed. So basically, the first one is accuracy. Accuracy is nothing but I am taking both the truths, true positive plus true negative, divided by the total data. So how many are correctly predicted? So in this case, it is 898 plus 36 divided by 1212. So 1212 is the total data. So you can very well say it is 934 divided by 1212, which should give you this 0.77. So possibly I'll just put up those numbers, right? So I'll say 950, no, sorry, 934. 934 divided by 1212. So you could clearly see, I think, my all right, let it run. I think I have to restart the runtime, looks like. Is my audio and video fine? Not video for that matter. I'm just asking about the audio because the file sharing is not happening. Okay, that's what I was worrying. Audio and video fine. Not video for that matter. I'm just asking about the audio because the file sharing is not happening. Okay, that's what I was worrying. Even this is Python is taking a good amount of time to run. Let me try to delete the runtime and again start. All right, otherwise I'll write it out. If my voice is fine, probably I'll not be able to run the Python code and all today. but we can discuss some of the conceptual aspects at least if my voice is not a problem. Otherwise, I think we'll have to reschedule this class because my Wi-Fi problem is not going to get clear today. Because even at a later point, the recording also may not come out to be good if it is breaking. So whatever you suggest, I think I'll go with it depending on how you are finding my voice because okay, after a long time this execution has happened. So should I continue? Let me hear from everyone or a good number. Tomorrow I'm traveling, Madhav Kumar, so tomorrow would not be possible. Thursday we can definitely have. So should I go ahead for some more time? Okay, I think majority of the people are asking for rescheduling. So see, let me tell you frankly, weekends are much tougher for me, Shubham. Please, I mean, I worked for Bits Pilani and I have a lot of my classes scheduled on weekends for the working professional. So I cannot take the class on weekends. Only weekdays, either mornings or evenings, I can look at. Right, probably we will have to extend our schedule a little bit. Even the number of classes is increasing because we have spent some extra time in the initial few sessions for Python and all, which were initially not planned. So we may exceed by some 5 to 6 sessions more than the 35 sessions that we have planned also. So I'll plan on weekdays only, but weekdays possibly I said I'll give only a weekly schedule. Okay, we'll continue for some more time as per Vigneshwari. Would that be fine? If things are getting worse, then we'll stop it. So at least we'll. Okay, we'll spend another 15-20 minutes and let's try to finish off this confusion matrix at least. And if things are getting worse, then probably I'll stop. Right? All of you have taken your time out to attend. So let me see if someone is saying that right now it is okay. So we'll try and continue. So what I'm trying to say here, is so the test data, the distribution is somewhere the accuracy is around 77.06. That is what we got here. So we get that accuracy as nothing but the total positive plus total negative. So this is what has been predicted correctly by my system. The remaining 143 plus 135, especially the 278 out of the 1212, is typically the error in prediction. So those much. So this model has not been able to predict more than 77% accuracy. But we know the default accuracy itself is 85% because we could see that the distribution is around 85.23%. So if I say that everyone will not default, everyone will belong to the group 0, then obviously it looks like my accuracy is 85%. Why do I really need to spend my time on such a kind of a model, which is going to give me an accuracy of 77%? So obviously this model can very well be scrapped, but we are trying to understand so how we can measure. Okay, this is one measure. Then the second measure that I am going to bring in here is called as the recall, or typically called as sensitivity. Okay, recall or sensitivity. What are we saying in this recall or sensitivity? We don't look at the entire data. Our focus is only on the events. So the events actually are, these are the events, the actual ones. The events are nothing but the actual ones. Actual default that has happened. Actual fraud that has happened. So we are talking about the actual defaults, actual ones. So what we are saying is, out of the total number of actual ones, out of the total number of actual ones, so actual ones are nothing but actual positives. How many of them have been predicted correctly? So in our case, out of the 179 actual positives that are there in the data, only 36 of them have been predicted correctly, and all the remaining have been predicted wrongly. So which means, so here it is as good as saying, for me, looking at people who have defaulted, how many of those people who have really been defaulted have been identified very much correctly by my model? If my model was able to accurately predict those people who have defaulted, probably it's going to be more helpful, because if I am able to predict the defaulters much early, it is very much possible that I can take the necessary preventive action as such. So that is the reason we see the total sensitivity or the recall value is typically 36 divided by 179. So it's approximately around 20%. So we could see here the recall value is our fifth value. So this is 20.11. So this is what, so which means sometimes rather than looking at the overall accuracy of the model, I might be more interested in looking at the recall value also. Out of the defaulters, how many of them have been identified? Overall, my accuracy might be 77%, 80%, etc. But the most critical set of people, which are the defaulters. So out of the total defaulters that are there in the system, how many of them have been identified correctly by the model? So that becomes a very, very important element. How many of them have been identified correctly by the model? So you can very well see that it is hardly around 20%. How many of them been correctly identified by the model, which is hardly around 20%. Okay. So that's the higher that metric is, sometimes it could be much better to go ahead with that model. Then third metric that we are talking of is, out of the total predicted ones, out of the total predicted ones, how many of them have been actually correctly predicted? So in the earlier case, we call as out of the total actual ones, how many of them have been predicted predicted correctly. So out of the ones that are typically predicted, how many of them are actually correct? So here we have 143, 135 plus 36, which is 171. So out of that 171, we are talking about 36 being correctly predicted. So 36 by 171, this is what we call as precision in prediction. Okay, you are predicting ones, which are very important for me. You are predicting ones which are very important. You have predicted that 171 people will default. Okay, but you are predicting the wrong guys will default. You are not predicting that so whosoever you have predicted, the model has predicted, only 36 of them have actually defaulted, which means the remaining 135 of the people whom the model said that they will default, in reality they did not default. So your precision in prediction, you are not to the point. Your predictions of the defaulters is not coming out well. So this accuracy is typically coming out to around 21%. The precision is coming out to 21%. So on all these counts, the model is not doing a great job. In terms of sensitivity also, the model is hardly 20%. In terms of precision also, it is 21%. Now this precision and recall, they are combined together, right, through this kind of a formula. 2 times the precision times the recall divided by the precision plus recall, which is called as an F1 score. So you can compute 2 times the 20% times 21%. So you can very well say this number this is the precision, this is the recall, so this is called as an F1 score. So the F1 score is around 20.57. This is what is the F1 score. So overall, you can take your decision. So what are the decision points for us? The first decision point is you can use the accuracy itself. You can compare 2 models based on the accuracy. Or just like now what I said, there is something called F1 score, which actually uses precision as well as recall internally. And based on that, you can say which model is a better model. That's the second. Now, you have already come, let me see the last question. It's again breaking. So let me know what to do. But at least this topic, is it coming out fine? Or all of you, I think right now you can very well suggest what to do. I mean, as I told you, my Wi-Fi is having a problem. I'm not getting any messages also regarding the possible cleanup. So some of you can suggest. I have no clue what to do. Then I think we'll reschedule. Probably let's not count this class. So we'll have the class again on Thursday, the same topic. Okay. Anyhow, we will go at a comfortable pace. The end objective is all of you should be comfortable. Right? Some network glitches which are not there in our hands. There is nothing much that we can do. Yeah. Okay. So my apologies for people because you have taken your time out, right? But yeah, we will try to see if we can fit in. We'll go only on weekdays as per the original schedule itself. We'll go only on weekdays. Probably I'll see in the coming weeks if I can give you more days in a week, right? And the problem is, I mean, we are not having flexibility in the timings also. So that is what is causing all the problem. And I cannot stretch beyond 9. Generally, 9 p.m. is my sleeping time. So I can't stretch beyond 9 p.m. So probably this is the only slot because this was the slot that was announced at the beginning. So if I am getting some meetings during that slot, we are losing out on that day altogether. Right. So I want you to please bear with me. And if there are some alternate sessions, alternate days or something which are alternate timings which are comfortable for everyone, you can discuss it in the group. And if there are alternate timings, which majority of them, I don't want to extend the slot timing because, as I told you, I can't go beyond 9. Right, by after 8:30 itself, you will see me yawning a lot, right? Because that's what. So our next class is on Thursday. Only this week I can take only on Thursday, Wednesday, and Friday I'm traveling, and I'm not sure during the GCA week. I don't know because many people would be traveling, and even the organizers would not be available. I'm really not sure how many sessions we can have during the GCA. But in the next week, we can try to plan a few 3 or 4 sessions, right? Yeah. So we will plan at a staggered pace itself. The only thing is, I don't want to delay it more closer towards the exams because we have some of our students who would be writing the actuarial exams as well. So I don't want to run into closer to those dates. That's where I'm trying to see if we can accommodate a lot of things in the here itself. Okay, so we'll try to extend until the end of March, as you rightly said. So today, let's call it off, right? Let's not count it as well. We'll call it off and we'll rework on the confusion matrix and the logistic regression in the next class. Once you get into some of the models, it becomes more and more interesting. So in the meanwhile, in the next 2 days, if you want to work on the data sets that I have given you, try to see if you are able to run all the aspects in those data sets until what we have covered till today. So that would be like that would be like you will get some kind of confidence on whatever we have discussed in a kind of a sequential fashion. All right. Then I think we'll end the session here. Thanks a lot, everyone, for listening to the session. And yeah, probably from my end also, some glitches. Yeah. Thank you. Take care. Bye-bye.